All right, now we're going to do the last free response on review day 8. Gives us a function e to the x cosine x. It says find the average rate of change. So we're just doing f of pi minus f of 0 over pi minus 0. And that should give us e to the pi cosine pi. Cosine of pi is -1, so it'll be a negative e to the pi. And then if we put 0 in, we're going to get 1 times 1, which is 1. Over pi. So it looks weird, but that's our answer, and that was worth 1 point. Okay. Part B, what's the slope of the line tangent at 3 pi over 2? So now we got to find f prime. So f prime, this is a product rule, derivative of e to the x times cosine x as is, plus e to the x as is, times derivative of cosine, which is negative sine. Okay. So if you have that derivative point, then we're putting 3 pi over 2 in. So the cosine of 3 pi over 2, if you think about that, is 0. So this will 0 out. The sine of 3 pi over 2 is -1. So we're going to get a negative positive e to the 3 pi over 2. Again, put them in for the trig functions and find those values first, and then that kind of helps us out for that. That was worth a point. Okay. Part C wants the absolute minimum value from 0 to 2 pi. So anytime we see maximum or minimum, we got to think critical point first. So we're going to do that down here. We're going to take our derivative. So we already found that, e to the x cosine x minus e to the x sine x. And we're going to set that equal to 0. If you did that, the AP gave you a point. Okay. When I move this over and divide, I end up with cosine x equal to sine x. And from 0 to 2 pi, that happens at x equal pi over 4 and at 5 pi over 4. Okay? If you found those values, you got a point. Okay? From there, what they'd want you to do is to actually then figure out what these values are. And remember, for an absolute, you have to include the endpoints as well. So they wanted you to throw 0 in, see what you get, throw pi over 4, and so on. So if you put 0 into the function, you're going to get 1. If you put pi over 4 in, what you end up with is, based on how we do it 1 over square root of 2, and then times e to the pi over 4. I believe that's what happens when you plug that in there. For the other one, you get a negative 1 over square root of 2, e to the 5 pi over 4. And then on the last one, you're going to get e to the 2 pi. Now, again, there's some weird calculations that make this happen. If you really want to know, just ask later. But if you work them out, this is what you should get. Now, we're looking for the absolute minimum. There's only one that's negative. So our absolute minimum is negative 1 over square root of 2 e to the 5 pi over 4. And we know that that occurs at x equal pi over 4, but they just want the value. So if you got that, that was a point. So you can see we can get 2 easy points right here, actually. The third point is a lot more work, but on your test, on your exam, get the points you can, right? Do what you can. Don't panic about something that looks really complicated. Again, just go after the points that we know we can get. Same thing here. We want to know for part D, what is the limit of this as x goes to pi over 2? So it's going to be f of pi over 2 over g of pi over 2. And f of pi over 2, if you put that in, you get cosine pi over 2, which is 0. So we get 0 over 0. Anytime we get 0 over 0, we got to think L'Hopital's rule. So now we're going to do the derivative of f at pi over 2, or g prime pi over 2. Now again, before that, it probably should have f prime x, g prime x, the limit as x goes to pi over 2. All right, so this is what we want to get to now. So the derivative of f, we've already done the derivative function up here. If you put pi over 2 in, again, cosine of pi over 2 is 0, so that goes away. Sine of pi over 2 is 1, so we're going to get a negative e to the pi over 2. And this is the derivative of g, this graph here. So at pi over 2, the derivative is 2. And so this is our answer. So the AP gave us a point here for this 0 over 0. They gave us a point for understanding that we had to use L'Hopital's rule, and we had a point for this final answer here.